we have the basic setup for our metadata system. So now let's actually take advantage of everything we have set up and start making specific metadata classes for specific different items. Because right now everything just shares the same metadata class, which just has a little counter variable on it. But if we have a sword, for instance, a sword might want to have different sorts of metadata, like having a extra damage enchantment or having a durability on it. So let's take our metadata class and make a blueprint of that, and we'll call this BP metadata. You could even get rid of the BP if you really wanted to. Let's actually get rid of it and just like make this the naming convention in this project. Everything that's going to be a metadata class will just start with metadata underscore, and we'll call this weapons, or just weapon. Now, strictly speaking, you might want a different hierarchy where you have a metadata class for the tools as a whole, and that will have things like durability and maybe enchantments like unbreakable, if we're taking something like Minecraft, that are to do with that durability, and then make children of that tool class to support the metadata for your swords or your shields or your other kinds of weapons. How you're going to set up this metadata object hierarchy, much like the actual item object hierarchy, is entirely up to you and your game. Just do give it a little bit of thought beforehand, because changing this after the fact can be a little bothersome. But for now, we're just going to make a couple of variables. So this will be our enhanced damage level, which will be a integer. Every level is just going to be adding 10% extra damage, something like that. So this is going to be an integer. If you just want this to be a flat extra bit of damage on top of the weapon's damage itself, of course, you could make this a float instead. And then let's also give this thing a durability, which honestly can also be an integer, because by and large, the way durability will work is it'll be a whole number out of a whole number. Which actually brings me to another thing, which will be the max durability. If you have a project setup that already has things like health, maybe, or mana, there is a good chance that you have something like a struct that holds a current and a max value. You might be better off using something like that for the durability here as well, which is going to give it two different values. These are going to be the values that the sword can have. So now that we have this, let's go into our sword item blueprint, the class, the weapon. And in here we can say what metadata class this is going to use. And now that we have a new metadata class, we can say this is going to use the weapon metadata class. That's really all that we need to do in here, because now when that gets constructed, we can see all the metadata objects that we have. A bunch of them are just metadata, but two of them, because I picked up two swords, are metadata weapon. So it does create objects of the right corresponding class. So now, how do we use those? The answer is the most scary thing to people who don't know what they're talking about, and that is casting. You could set up interfaces for a bunch of this stuff as well, and specifically for things like durability, it's probably good to set up an interface instead, if you don't have a very strict hierarchy where durability is added in like one step of the parent-child hierarchy. And instead you have a bunch of different classes with all kinds of like durability stuff. It might be good to make an interface to get that through that method instead. But let's just put in a progress bar and make that a child of this overlay as well. And we'll just kind of put this progress bar in roughly the same spot as this item slot, and then make it go a little bit lower as well, maybe a little bit lower still. That's pretty good. It's just a little bit tiny at the moment, so let's do something with that. For right now, we're going to kind of hardcode this to only work with weapons. You want to set up a interface for this, realistically speaking, or just structure your hierarchy for your objects a little bit better. But we're going to go into the item slot here, and in the item slot we're going to add one more thing, and that will be a progress bar. So we'll add a progress bar, which we will add in the overlay here, and we'll add that at the bottom, and we'll make that like just as wide as the slot itself. You can just keep it blue for now, that's fine. And we will check at the very end here. So if has item is false, we definitely want to be setting this thing to visibility hidden. But we also want to check at the very end here whether or not what item we have in our item slots, the metadata, whether or not that is of a type weapon. So let's get this inventory slot and also move it like all the way over here. And then we just want to cast this to weapon metadata. Again, if you set up a interface for this, it's a lot easier because then you can have a bunch of different things with metadata, and just as long as something returns some type of metadata with a durability in it, it'll work better. Because now if you also make tools that have durability and stuff like that, it doesn't really scale up that well. For now, this will do as an example. If that cast fails, we clearly don't have a weapon on our hands, so we want to set this visibility to hidden as well. But if this cast does not fail, we have a weapon. So we want to check, hey, do we have, we want to set that to, so we want to set it to visible instead. And then we want to set the percentage to being based on our get max durability and get durability. And then we just simply divide the durability by the max durability to get the percentage value of how much we have left. You will note that these create these normal light blue integer lines. So that's not what we want. We want to actually set these to take in floats, so that it will also output a float. Otherwise, it's going to truncate and it's just never going to work. So durability divided by max durability, and then it's going to be outputting a float. And if you want to be really sure, you can add these to float, so that it actually uses floats to do the division as well. I never like doing actual math with integers, so that's why. I almost forgot to give these default values as well. We'll talk about setting specific default values up at some point in... So for now, let's just say the max durability is 10, and we'll start the durability, of course, then also with 10. Of course, you're going to want to set the default values for these on a per case basis for your item. So your item itself would, for instance, have 100 durability, and when it gets created initially, it will take that information for the durability and pass it along into its metadata object. We'll probably do that along with creating items that have metadata to begin with, like making a function that just takes in metadata so that you can make a chest that has an enchanted sword in it without you having to like go ahead and enchant it or whatever in a separate video. But for now, we'll just put in max durability and durability to 10. And now we will see that this thing has a little progress bar wherever it goes. So it has that durability. And even when it goes over here, it has a durability. It's a little bit squashed down because of the aspect ratio of the screen. But we have that. And we can even try to like pick up some rocks here. And in theory, if we craft a sword, it should also immediately show it with a, there we go, progress bar. So that works. Now let's see how it works when we use up some of that stuff. Because the idea behind durability is that it will go down. So for, again, testing purposes, because durability can go down in a lot of ways in your actual gameplay, of course. So we're just going to add in a debug key on the character here. We already have a debug key for F. So we will just get the inventory component. We will query single slots. The item we'll find will be our sword. And we'll just try to find one of them. And then when we find that inventory slot, we want to break that. Want to get the metadata. Want to cast it to the weapon metadata. Because we already know that we're working with a sword. We already know that this is going to have weapon metadata on it. Because swords get assigned weapon metadata. And then we can just kind of get the current durability, and we can set the current durability. This could be a function on here instead. It's just like subtract durability. Matter of fact, let's just do that. That seems like a little better to do it that way. So we'll just take a function, subtract durability, and we'll just take our durability and decrement it. It's really just as easy as that. And then we'll add a returning node with an output should destroy, something like that. So if the output there now is less than or equal to 0, we should destroy it as well. So we can just subtract durability from that, and we'll get back the should destroy. I guess if should destroy is true, what we want to do is we want to get an inventory component. We want to clear inventory slot with the index corresponding to this inventory slot that we're working with. Now, I don't think this is going to be updating the progress bar yet, because in no way are we updating the UI here. So we'll probably see that if we do this 10 times, it's going to be destroying the sword that we pick up. So let's try that. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It destroyed the wrong item. And then once it redraws the entire inventory, it did upgrade the progress bar. Why does it destroy the wrong item? It seems like when it initially gets added to the inventory, it has a index assigned to it of 0. That's probably something to do with this world item actor, because I haven't looked at that in a while. We try to add item, and if item is added, we... Okay, so add item itself. We'll add in the array index. This just adds one. Oh, it's always setting it to index 0 here. So it should be doing this over there. So I think when we created this metadata thing, I disconnected some stuff and didn't reconnect everything properly. So now it should all work properly again. So it should be index 1. There we go. So if I press this just 10 times, it deletes the item there. But every time we use upper durability, we won't actually see it update, right? Because obviously that's what we want. And honestly, the easiest way to just do that is to go all the way back here to before the branch node real quick, get our inventory component, and we can just call on inventory changed. Because our inventory did technically change, so it's just going to redraw the entire inventory for us every time we do that. And when it redraws the inventory, it's going to rerun that code and update the progress bar. Do we need to rerun the entire inventory for that? Technically, maybe not, but it's not that big a deal. So we can see that we are using up the durability here, and then eventually it disappears. So the durability now works. Now, we maybe want to do something a little bit better. So if we set up the inventory utils blueprint interface that we have here, we can just start adding some stuff. So we can start adding get durability, because this is going to be a thing that happens on a lot of classes. And being able to do this without casting is probably a good thing. So we'll take in the input of... So we don't need any inputs here. The only output that we're going to be doing will be the max durability, which will be an integer. And then we'll also do the current durability. And then we probably want to... And then let's make that subtract durability thing an interface, because there's a good chance that it's going to have to happen on multiple different things. And maybe sometimes on some things we want that to behave differently from other things as well. So this is an alternate way to do it. I don't think you necessarily need to do it this way, depending on how you architect your project, but let's just go over it real quick. So subtract, we're just going to call it subtract dura, because I'm too lazy, to be honest with you. And it'll have two outputs, the new current durability and the max durability. And if we then go back into our metadata here, we can see that we now have this subtract dura function, which is part of the overridable functions, because the parent of this class, the WBP metadata, implements the interface for this. So this also has access to it. And here we'll just get our current durability. Again, just decrement it. The functionality is going to be the exact same, but we won't need to be casting anymore for this. And I suppose what we actually maybe might as well do is has dura as an output and make that a boolean. By default, that's just going to return false. That's an easy way to check, hey, did this interface actually do anything with the object that we requested it from? Because otherwise it's just going to be returning the default values. But if it does do something, we can refresh this node, and then it will return has dura as true. The new current durability will return, and then we'll also simply just return the max durability. And now we don't necessarily need to have this weapon metadata cast in there. What we can just do is we can just subtract dura as a message. And now anything that implements this will be able to interact with this fairly easily. And the has dura will just be... So we'll just put in a branch here for has dura. If it does, we don't need this one anymore. I guess we might as well also, while we are at it, add in the should destroy in here, so that we don't need to do it at every place that we are getting the durability. So we can just check whether this is less than or equal to 0, and we should destroy. And then right click, we can just refresh this node. Now we have should destroy. That can just go straight into there. And now this will work the exact same way, but it is an interface. So for anybody who is losing their mind that I'm using casting, there you go. We have an interface and it works the exact same way. And now technically it is more scalable if you're inheritance hierarchy is a mess. I think next time we want to talk about setting default values, some of this stuff, which, to nobody's surprise, we are going to be doing with interfaces. We're just going to make interfaces for every single potential set of default values. And then we'll also take a look at making items generate in chests or just in your inventory that have custom metadata on them to begin with, because those two things will likely take up a lot of the same basic understanding of how the code works.